Lesson 38. It's a slight modification from another classes, but that's okay. It's lesson 38B to get us caught up from some of those snow days. So this is, go ahead, I am out today because I have parent conferences, this is during the pandemic, but go ahead, answer the do now, okay, and then we'll go over it, okay. So pause me if you want to try it on your own, but if you're ready, then we can go over it. All right, so we're studying systems, and one of our big things is that a lot of real-world problems are involved systems and can be solved using our methods. It's actually going to be part of our standard that you can actually take a word problem and write the two equations. So this is our beginning of that. All right. An oak tree that is 2 feet tall is growing at a rate of 1 foot per year. Write a linear function in y equals mx plus b form, which is our slope-intercept. Okay. It has a constant rate of 1 foot per year, so we have our slope, and we have a starting amount, which is 2. So the equation for the oak tree's height is y equals 1x plus 2. Cool. The next one, a 6 foot tall maple tree is growing at a rate of 0.5 feet per year. Write a linear function in y equals mx plus b form for this one. Well, again, we have a constant rate of 0.5 foot per year, and we have a starting amount of height, 6 feet. So y equals 0.5x plus 6. Okay. Question 3, and I'm stepping through it because it's our first time doing it. How many years will it be before the trees will be the same height? Would it be 1 year? Will it be 2 years? Will it be 3? Will it be 4? I guess we could just keep checking x's, right? Plug in different x's and find out when. But we're going to try to approach this using a system. So we're going to first, should have put the two equations in to our brackets. This is system notation. All right. And now we can solve the system. Because we talked about it. These both equations say y equals. Just like Mr. Moran equals y and awesome equals y, we can say Mr. Moran is equal to awesome. So that was how we thought about that when they're both y equals. So this equals y and this equals y, then they are equal to each other. So we can put the equations together. Boom. So that's our new, our one new thing, right, that we learned. And so we can put these two equations together because they both say y equals. Everything after this you've learned before in practice. We're going to solve the equation. Take away 0.5x from both sides. And then we're going to divide both sides by 0.5. And it is not equal to 2. What? Yes, because it's saying how many 5/10ths will fit in 4, right? Or 50, if you think of this like 50 cents, how many 50 cents are there in $4, right? So 0.50, 1, 150, 2, 250, 3, 354. So we can actually fit 8. So x equals 8. Great, so now we know 8 years later they'll be the same height. And we answered our question. Say we wanted to know like how tall they were after 8 years. You can pick one of the equations and plug 8 into it. And in 8 years, they'll be 10 feet tall. Okay, so we talked about that after we graphed linear functions to find where they cross. We found that we can use this new method of Mr. Moran equal awesome. Okay. There was no homework because we're a little bit behind the other class, but that's no worries. This is 5.2 substitution method day 3. Okay. So if you're taking notes, write down the heading, not this next stuff. All right. To solve a system of linear functions, we need to find where the two lines cross the x and y. That makes both equations true. Right? We're trying to solve systems, we find out where they cross. Right? It's also the x and y that makes both equations true. The example we already just saw early on was that when y equals Mr. Moran, y equals awesome, then we're allowed to say Mr. Moran equals awesome. Right? And that's like the first idea of systems, solving a system using substitution. But what we did is we ran into, I forget if we got super far in this, but I think we thought about it. The directions are to solve the system of the linear function using the substitution method. I had you write down these two equations. Somebody read them. And then I said, oh no, both equations don't equal the same variable, like in Mr. Moran's problem. Does that mean we can't do it? And no, it's not that you can't, well, I guess, I mean, it doesn't, they're both y, and so someone always says turn this into y equals, which we can, but let's think about what that word substitution means, right? And so it might have been your class or other classes, but I said, what does substitution mean in math? And you might have said it means to replace or switch, or, which you lie about, that Miss Connors says, oh, substitution means to plug and chug, right? Okay, so you've done problems like this one here. How do you find out what x equals for a problem like this? If y equals 5 and x equals 4y plus 8, can we find x, and how do we do it? If y is 5 and I have this, how do I find x? Students like, well, you switch the y with the 5, right? You plug it in, and then you can do the math. And you did that in 5th and 6th grade, I'm sure of it. You substitute things in for something else. You replaced it. So since we knew y was 5, we can put 5 in for y. That's substitution. And you're like, yeah, okay, I remember that. We even did that in chapter 3 and 4, right? We substitute stuff into the equation. All right, so keep that in mind. Are you ready? All right. So that same problem, which hopefully you wrote down. Oh no, the equations don't equal the same variable. Who cares? Which is awesome. As long as one equation equals a variable. And we do have that. Ours tells us that y equals this. And we have this other equation. Well, we can use substitution to find our answer. Sorry. Let's do this. Like, think about the last problem we just did. If y equals 2 here, and I said to substitute, you would put it in here for y, right? And do some math. That's substitution. So here's where it might be something new. We're going to substitute this entire, not just 2, but 2x minus 6 for y. So y equals this, and here's y. So these things can swap. You can substitute them in. So this is what I mean. You have 2x plus 4y equals 16. But you know that y equals 2x minus 6. So I'm going to substitute it in. I'm going to take 2x plus 4y. And the only thing I'm going to do is switch the y out with what it equals, which is 2x minus 6. Substitution. Just like if it was a 2, I could put a 2 in for y. We have to put something else in. Okay? And that is the one new thing. Okay. We can substitute a part of one equation into another equation. That's kind of brand new. But everything I'm about to do next is not new. We now can solve this for x. You can distribute, which you learned already how to do. We know that we can combine like terms. And we learned that we can solve equations by doing things to both sides. And yes, you know, it's a little bit of work, but in the end, this is the only new thing. Putting that in for y. And everything else is the same. Okay, but to solve a system, we need to find the point where they cross. So I'm going to take the equation that says y equals 2x minus 6 and use substitution to get the answer. So these two lines cross, and we can use substitution to get there. Awesome, right? Okay. You can remind me because this is a video, but here we go. Next thing. Here, write down B. See if you can use this new substitution, right? But you know substitution, so maybe it's not that new. I'm going to keep going for time-wise, but pause me if you want. Okay, I read the equations. Blah, blah. Well, this one says y equals, so I'm going to circle this piece. I see y in the other equation, so these can be substituted in and out for. So I'm going to take y plus 5x equals 24, and I'm going to replace y. Technically, there's a 1 in front here. With the thing that y is equal to, which is this 3x plus 20. Replace this with that. Again, that's the one new thing. Now we can distribute. Combine like terms. Solve for x. And we can choose one of the equations to find the y. So we found that these two lines cross at 1/2, 21.5. Okay, we found the numbers that make both equations true. All right, and here's one more for you to try. So pause me now, might be a good chance to pause. Okay, so you've paused me hopefully. I read it. One says y equals, this top one. I see that that y is here, so these can get substituted in for. So 3 parentheses y minus 4x equals 19. I'm going to replace y what y equals to, which is 3x plus 20. Substitution. Okay. Now that's, again, the only new thing. Everything else, you already know what you're doing. We distribute. You get 9x plus 60 minus 4x equals 19. Combine like terms. Solve for x. You get negative 8.2. Whoops. Okay, we can take that and plug it into the equation. Okay. Cool. Oh, sorry. And then, you know, that'd be hard to find. We couldn't find that on a graph. We couldn't even guess it. You know, maybe it would take forever. You could try it, I guess. But now we know that these two lines cross here. Great. So here's what you got for class. Hopefully that video makes sense. You have a graded classwork, okay? We would do it in groups, but we're not. So you just have a graded classwork. This, you find it in Google Classroom. It's due on Tuesday by 11:59 p.m. Okay? I want you to get it done now in class. Okay, it's 6 problems with an extra credit. It's going to be graded for accuracy. Show your work. Okay, it says it on there. And the homework is posted. This is due on Thursday. Okay, when I see you again next. All right, everyone, that's the lesson. Make sure you do the graded classwork during class, and then the homework is posted. It's 4 problems.